Welcome back again. So we will start our discussion on the alternative fuel and vehicle scrappage policy and environmental perspective. So we'll continue our discussion in this particular section. So we have been looking up at this particular one, how I contribute to the policy making. This is a question that we wish to answer in this particular session. For the past 5 days, we have been looking into multiple activities of the supply chain of the alternative fuel sector, specifically transportation sector. So this is the typical point where to start and who will participate is the biggest question. So do we have really an achievable strategies in the Indian context? Do we have sustainable payment research being done? Is the attitude and behavior of the Indian with a very diversified system, can we achieve it? Are the alternative fuels with the policies that what we are making is necessary to be fine-tuned, or really do we have a complete picture of what actually is being done will achieve the necessary goals and the targets that we have placed? Is the infrastructure that we have developed to implement all the policies is sufficient? And do we have really the collaborations between institute, industry, and government? And what about the research that is being done? There are a number of questions. Where do we start? How do we start? And who will participate? Who will take over this particular one to create a great link between institute, industry, and government, and which brings help to our citizens, and in turn we maintain the environment in a nice approach. So that's the biggest question that we have. And in the day one session, we have been discussing on the full layer type supply chain of different system boundaries. And we have from extraction to the combustion for our traditional fuels, whereas from agriculture production till the usage and disposal to our alternative fuels. So, and similarly, this natural gas as a transportation fuel, if you just see, we have discussed on different system boundaries that we can do, that from production to the fuel pump, if you are bringing, it will become well to pump. Whereas you are looking from your pump to the vehicle operation, it will become pump to wheel. And if you are looking for the full life cycle, it is well to wheel. So the biggest question starts, like I've given you a lot of examples over there without putting a context into the picture. As I said, I am an environmental engineer who is practicing to think in sustainability aspects and life cycle design. So how do we actually contribute to this particular from an environmental perspective? So all the activities that we have been doing and the systems that we are following to do this particular at different stages, I'll be discussing now. And further, there might be multiple people who come from different backgrounds, like there might be economists, there might be agriculturists, there might be some financial people, there might be technocrats, industries people. So it is now left to your choice to start igniting your minds from your own direction. It's like, basically, it's my own perspective I'll be presenting. I would love to hear all your perspectives, which will help me in designing a system. So that's the stand I am taking now, and I am going from section to the section. So production, manufacturing, how we do, then utilization, how we are doing, at the end of life, how do we do? That is where I integrate the topic title, alternative fuels and vehicle scrappage, cradle to grave. So the first step in the life cycle assessment that we see is the raw material extraction. So I'm not speaking much onto that particular sector now, but because in the transportation, I'm looking at I'm starting from the point of production and manufacturing of the alternative fuels or the basic conventional fuels. And then the utilization phase, how we can do a small amount of life cycle assessment activities, some few examples I'll be presenting, and finally the scrappage policy, how I contribute from the end. This is the broader content I'll be covering in this particular presentation. The first step is the production and manufacturing that we'll be looking in. In the production and manufacturing, one example that I'll be taking is the life cycle analysis of a biofloc production system. So here we have worked with Pradeep Ramesh, who comes from Tamil Nadu, it's like Fisheries University. It's a collaborative work from our laboratory, where we looked in the production of shrimp fish. But although it might not be directly related to the alternative fuel production, But the algal biomass production is almost will have a similar steps. The steps for production were very much included. So I'm taking this particular base example for my overall description about how do we conduct a life cycle assessment here. So we initially, by following our ISO 14044 principles, there will be a life cycle inventory definition that has to be developed, for which we have developed our goal and scope system. The framework is literally being shown. The stage one is the inventory database development, followed up by an impact assessment, and finally an outcome called development of aquapat values has been performed. So the picture that you are seeing here is the system boundary that we have considered, where we have 3 steps we have placed: production, processing plant, and the market. And to the production plants, there are different hatcheries that we have selected, and each hatchery, from each hatchery, we have to collect the data. So this is the system boundary that we have considered for our work. So the functional unit of the system is defined as 1 ton of processed shrimp. So to get this particular one, we have a hatchery, biofloc farm, and a processing farm were included. We didn't use the feed mill raw materials and this transport associated in the brood stock. So we didn't consider all these things. And always remember, LCA is a user-friendly technique where you can include and remove many aspects, and you can expand your system one by one, and you can achieve a lot of results. So that's the reason why we define the system boundary. So post defining the system boundary, this is a data collection. As I always said, data collection is one of the heart of the LCA. So you can see the man standing over here is a Pradeep Ramesh, who has been continuously visited 2 hatcheries, Royal Shrimp and Dolphin Shrimp hatcheries in the Tamil Nadu. Farm is High Tide Sea Farm in Shikharji, and the processing plants Ashwini Seafoods Limited in Tuticorin and Avanti Seafoods Limited in Andhra Pradesh. So he has conducted almost the inventory studies from the real-time farms for almost 4 months. He has been visiting all those, conducting the experiments, collecting the data that is available. And the biggest challenge that we have faced is making them understand what data exactly we want. Because the data that is available in the industry is not according to the inventory database that we want. That's the biggest challenge. And there were many questions to a lot of people whom we are associated with, that we can't generate this much amount of data. And we have some certain targets for our industries. So we process based on those particular aspects. So any person who is practicing life cycle impact assessment works or sustainability design should develop their own data templates and share with them with the industries, so that they can collect that particular data, or they can do that particular calculations for you. Or if you can give good amount of time, they can start streamlining themselves in processing that particular data. And I can give you one example. Suppose there is a process flow. So then electricity is being supplied at a process flow, and the industry will collect the overall electricity consumption, not from unit process to unit process, step to step. So that minute level data collection will not be done at the industry levels, because the targets are different. They have to achieve some certain goals. They have to meet the demands. So they have to set running with this particular world of competition. So it is we as a practicing person have to go them, tell them that you can install this sort of meter, and explain them how green they can become. And automatically 1 to 2% of the investment, if they can do, they can collect huge amount of data, and developing that particular inventory databases will give a very, 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 very excellent ones. So the database has been, we have conducted series of field investigations over here, and you can see Pradeep is collecting different data samples from there, and a lot of discussions have happened with each and every individual farm which Pradeep has visited, and a very good database has been developed. So I'm not showing the inventory database completely, because it will take a lot amount of time, and so directly we inputted that particular inventory into the CIMA-Pro results. So how I conduct impact assessment is not a big task. Why? Because you have ready-made softwares, or you can have Excel sheets developed based on your needs, and you can calculate that particular. It's completely a mathematical approach. But since we are looking at from a policy angle over here, So inventory database completeness will play a very, very, very major role in the outputs that you're going to get. Once you have a beautiful graph of this particular sort, right? So what does this graph mean to me? You can see carcinogens, non-carcinogens, climate change, like global warming, mineral extraction. There are a number of impact categories. So what does this bar mean to me? How does this bar will really help me in making a policy? So as a technical person, I look at global warming and I can see the farming activity has more amount of greenhouse gas emissions. So now the time for me is like I jump into that particular farming activity, see each and every individual component, and again calculate in farming, which is the more and more global warming contributing unit process. Post that particular one, since it is farming, I am not a farmer, I am not an agricultural person, I am not a geology person, biology person, biotechnology person. I don't understand what is happening in that particular process. So that's the time I connect with my other technocrats, industrialist people, start understanding the process, take their opinions, what are the green alternatives that I have, and start developing scenarios. I put this particular farming scenario as my business as usual scenario, the existing current scenario. Then I'll ask, so oh, I have an alternative one, I can implement this particular one. So what could be the impact of this process when I implement, how much it is going to reduce my global warming potential. So start developing different scenarios, start conducting a good amount of analysis on there. So each and every step when I am doing, I am developing one set of inventory database, which is contributing to my Indian context. And second, carcinogens, non-carcinogens, all the list which I am seeing, are they really important in the Indian context? Do we really have an Indian specific impact category? As of now, till date, I haven't never seen. We all know global warming is important, but really, if you can see something like ionizing radiation, is it really important? Who is much worried about ionizing radiation? We have seen that mobile phone will create huge amount of radiation, but how many of you really know how to come over with that or combat with that? So it is again the time that we will develop it's like India-specific impact categories where we want industry people to come into the picture, government people to come into the picture, academicians to come into the picture, all the stakeholders should come into the picture. So otherwise, you can't build an Indian-specific data, Indian-specific intervention. And certainly, when you go and sit with the policymakers, if you can tell them what is possibly that you can do to this particular country is very, very important. It is not the action of concern, it is action of influence that we require to say. Because policymaker, when he sits in that particular seat, he always wants to see whether he is able to achieve the set standard goals and targets. So it is that we are like feeder sources for them. So let's make the Indian specific achievability in SDGs or our goals true by 2030 or 2050, whatever we are talking, by giving our interventions. That's the key take home for this particular one. So post, you have seen the production space from this. Now, how can I use that particular produced ones? Suppose I have grown all microalgae in that particular system. So I have collected, went to a hatchery, went to a farm, processed all this particular microalgae. So how can I convert this particular into a biodiesel fuel? So the discussions, I'll give you an example, but there are very good amount of discussion papers, white papers that are available from different sources, from where I'm using one of that particular one. And National Transport Decarbonization Council has verified this particular one using good number of studies. So do contribute to this sort of databases. So first question that comes is the diesel consumption we are having, where 87% is for the transport and 13% is for the non-transport sector. So that's the reason it is very important for us to look at the theme of this particular conference, decarbonize the transportation sector, out of which 64.2% is from the trucks, light vehicle and heavy vehicle units. And you can see if we can target this particular section very clearly, so we can achieve some of our standards, and rest all sections will follow what we are doing. And in this particular section, I'll be presenting you a life cycle assessment of microalgal biorefinery. This is a work that has been done by our team, and the main lead is the Sanjukta Banerjee, who is working as a faculty in NIT Tadepalligudam now. She has been passed out in the year from the research program from Department of Biotechnology. So it's a collaboration that we have done. So you can see the different number of challenges that we have in the current 21st century. The population is increasing, and it is expected that by 2050, the South Asian countries and the African countries will be 1/3 population all over. And it is very, very, very important. And already India has become #1 in the population explosion. And next key critical component is the energy crisis that we are having. And as per the limits to growth curve, when we see the population is increasing, the resources are decreasing, pollution is increasing. That's what you can see: waste management, fossil depletion, climate change, all these are happening. So looking at all this, what could be one critical solution that you give is the environmental policy. So did we get our environmental policies right? Oh, if they are right, let's look into the National Green Tribunal cases that are being handled, which is a quasi-government activity which looks at the environmental standards and environmental schemes implementation. There are a huge number of cases across the country which are associated with the environment, and the Green Tribunal is resolving all these particular aspects. So there is a dire need for involvement of multiple technocrats, academicians, and into the policy making. So yes, we'll just look that particular from a point of view of biofuel. So we have a very good progression in the feedstocks of the biofuel production. We have been hearing this particular from Professor R.K. Sen in the yesterday's session, and the industry people from DM Giriji and Kushal Mittalji also have been explaining how the progression is happening in the biofuel sector. There are first generation, second generation, third generation systems, and we are now working with all these parties. And typically the ITF project which we have done is to develop the database for alternative fuels from second generation and third generation biofuels. So in this particular LCA, we are looking into the microalgae. So this particular microalgae will be used as a protein supplement. So there is a food component or nutrition component that is associated with this particular microalgae. And similarly, there is a biofuel production component also has to be taken care. So, and similarly from this when you are using a food crop to your fuel one, there should be a striking balance that you meet the requirements of your nutrition and then utilize this particular one. If you remember the 17 Sustainable Development Goals, I would say them as the ranking that has been given to all the 17 Sustainable Development Goals. The first 5, one will be catered around the social, like zero hunger, or no hunger, zero poverty, no hunger. So each and every one, you are improving your life standards, then come into the system where you are having sustainable communities, innovations coming into the picture. That's at the demand change, and then we will move into the environment, climate change, life below water, then partnership goals. See, from the mission life side, when you see change in demand, change in supply, and change in policy, that would be a very striking system when you see your sustainable development goals. The link has been well made in that particular one. Are we progressing in that particular direction? The biggest question again. But however, at this particular junction, we'll see microalgae has 2 applications. One is a protein supplement, and second one is a biofuel production. So we are taking the line of biofuel production where you can check out biodiesel, bioethanol, biohydrogen, biobutanol. So there are 4 components that can be achieved out of this, out of which we are looking into the biodiesel section. So this is a system boundary that we have studied. Microalgae biofuel production under biorefinery approach is the component. See, again, I am not a biotechnology expert, so I've sat with the team over there, and we brainstorm on what can be included in the system boundary and what has to be removed in the should not be included in the system boundary. So we have taken a pilot scale process of this particular one and made assumptions to reach the industry level. And the production, the functional unit is 1 kg algal biomass production is the functional unit for this particular system. So microalgal cultivation, moved into the in situ electroflocculation system, then drying, pigment extraction, lipid extraction, saccharification, fermentation process, and anaerobic digestion. So at each and every sector, you can see the complete main flow, and there are products coming out. Biodiesel is the product, bioethanol is a product, biomethane is a product from one component. So here we didn't took bioethanol as our functional unit. So if we take bioethanol as our functional unit here, from microalgal to lipid extraction will become the main process. Then bioethanol and biomethane will become the byproducts. Or I can take two functional units, production of biodiesel, production of bioethanol. So I have multiple types of looking at my functional unit based on the requirement that I am doing. For example, I have a biodiesel industry. So I'll take biodiesel as my main functional unit, right? Because all my processes will be associated with this particular. But in this particular study, our aim is to produce 1 kg of algal biomass. Post that particular one, how they can be applied to this particular one has been investigated. So to each system, we have seen what are the inputs, what are the outputs that we are getting over here. And if there is some sort of recycling that is being done, and we have considered those recycling scenarios, and we have moved on. And good inventory databases have been developed. We have taken, it's like consulted electrical people, instrumentation people. Well, so lot number of people were involved in calculating each and every situation. And whenever we face trouble, a technical person has to come and tell us why it is happening this particular way, how you can implement that particular one. I'll give you an example over here. Basically, since this is a pilot plant, when we are shifting it to the industry scale level, so what could be the additional electricity requirements that will be happening is the biggest question for us. So that is where we have approached the manufacturing section people to understand how the scaling will be done. So after understanding that, what assumptions that can be incorporated in this work, they considered, and they're well drafted and placed into the system. Suppose that particular, once a nice inventory database has been developed, so you'll be very, very, very clear with what exactly you can do with your system. So you just incorporate it into any software that you have, just calculate the results. So once you have this particular beautiful graphs, again, the question comes, how do you interpret this particular result? So if I can just see from the pink color graph, which is for climate change, again, microalgal cultivation itself is creating huge amount of pollution, I would say emission over here. So in the cultivation process, when I say algae, it is a good, it's like one good sink for the carbon dioxide. So you have to understand that particular process, how better you can remove that particular one. You have to verify with the experts over there. And that's where the people are working on that particular one to reduce this particular impact. So once we are given this particular result, yesterday you might have listened to Professor R.K. Senji, where he was explaining how they are modifying those particular processes, how they are bringing in the efficiency to the system that is being developed over there by putting lots and lots of green controls and green technologies over there. So that's the beauty of integrating. That's the beauty of transdisciplinary approaches which we are having. And the R&D units of the industries are working effectively to minimize their emission losses as from the processes and everything. And similarly, now they're putting up their thought process on decarbonizing their particular systems. So this will be the biggest chance that the industry as well as the institution has to join their hands, and which is happening. We have to accelerate it more. So that will bring a very good policies to achieve our goals in a short span of time. So once we have conducted all these particular studies, the previous one which you are seeing are the characterization results. So we have identified the hotspots in that particular scenario. This I can show you, go back, like the microalgal cultivation, pigment extraction, biodiesel production, and ethanol fermentation, and are the 4 key component ones we have taken. And post this particular one, we have conducted a sensitivity analysis using sensitivity analysis. So by varying the electricity, so there we have considered the Indian electricity mix. That particular one, at that, it's like it is conducted at 2021. We have started this particular one. At that time, we are almost at 60 to 62% of the coal content. And we have taken this scenario and we have selected cities like countries like Brazil and China, which have a similar energy mix with us, and we have compared this particular one. And then we have Norway, So which is one of the very beautiful systems are there. I will explain you in the few slides why I say it is very beautiful, but it's a non-achievable system for us. Yes, they have almost 90 to 95% hydroelectric power stations, whereas in India we can't achieve that particular one because everywhere you can't implement hydroelectric power stations. So typically when you go with that particular thought process, you have to see what are the alternative energy systems that we have, alternative fuels that we have that you can bring out for running. Instead of running a diesel set in it's like genset using a diesel, you use an alternative fuel. As you use solar power plants. Every problem has a solution and every solution has a problem. So let's solve our problems by tailor making all the solutions to Indian context by understanding the Indian systems. So that's the policy how we are to move on. This is a sensitivity analysis that you will get. So now after looking into the production system, so how I contribute to the policy making in this particular. Again, all the challenges that I place, all the evidence-based policy directive points which are there cannot be addressed by me alone. It's like I can contribute only to the few sections. We want hand in hand to go to achieve all these particular aspects. So what are the challenges that we have? Identification of domestically available potential feedstocks. So India is an agroeconomic based country. So we have huge number of crops being grown. What potential do we have? What can be grown? Where the agriculturists have to come into the place and explain us how we can do this. And involving local support from the optimum for the optimum production. Again, social aspect studies have to come into the picture. Economics have to be seen. Attitudes and behaviors have to be studied. So there is a big task for us. Role of government and other concerned organizations. So in the day one, we have seen what central government has, what policies and which ministries are there, who are working on that. Always we have to remember is that once a policy is made and declared, then it is to be taken granted for that particular time. So we cannot debate on the policy, we can improve the policy. So my take would be debating on the policy, whether it is implementable or non-implementable, is again and again, the think tanks are questioning ourselves. So let us start changing our thought process from questioning whether it is implementable, then say how it can be implementable, why it cannot be implementable, and what should be done to implement it. So automatically we'll get an amendment in the policy directive immediately. So that is how we can progress. So I hope how we can implement all the policies is well known, and how we have to take the way forward is to be well discussed and setting attainable goals. So I don't know, I'll put up my personal point from the waste management sector that we have placed the goals which are very, very ambitious enough, but are they really attainable? Is a question mark that you see when you segregate your waste at your homes and when you give it to the local authorities, when they're mixing it in your locations, you can feel the pain. So it is important that whether we developed our necessary infrastructures, we have tick marked all our boxes, are we progressing in the direction? So setting the attainable goals is one of the important challenge for us. And specific to the biodiesel fuel activity, develop a fuel quality standards. Extensive amount of testing has to be done. We always see that BS4, BS5, we have skipped BS5, we have moved on to the BS6. When we are trying to implement BS6, is our system ready to meet that particular standard? Do you have that particular enforcement? Do you have our industry people really reach that particular standards with the proper funding being given to them, proper exemptions in the customs duties, etc., being given to them? Is there ample amount of research being conducted in our academic institutions? Is the government enforcing people to use this particular? The connection has to be well seen. It is like one link fails, all the system fails. So what can be possible evidence-based policy directives says like biodiesel blending to achieve the national targets. So we are putting up our targets slowly from action to the action. And so how do you achieve it? The Ministry of Fuels has to take care of this particular one. And I hope there are many people who has to contribute to this. And regulating pricing mechanism and ensure its cost competitiveness with non-blended diesel. So economics has to be studied. provide buyback guarantees to the biodiesel product producers, mandate public sector vehicles to use blended diesel. So I'll give you one best example from this again, why I say public sector here. So we say it's like we are banning all the banners from now. We go to the cloth banners. But immediately once this particular call comes, you can see a nice banner comes when our like public sector people, when they enter, you'll see a full length of banners which are plastic in nature. So be the change you want to be. So it is if we are given a call to something, let's mandate it. And you enforce a lot of things and violated the same point. So who has to be made responsible for this particular? It's a multi-million question place. So whatever I am placing are academically neutral and factually true. Academically neutral and factually true. So if there are any differences in the opinions and everything, just don't take it into the personal mode. Why? Because with the hard facts, I am placing this particular one. Exemption from the custom duties, income tax, and sales tax on the biodiesel. It is very, very important that it is a taxpayer's money that is being used to develop all these particular systems. So 100% of thought process and self-resilience, self-discipline should be there when we are using this particular money. So when we give exemptions from custom duties, income tax, sales, all these particular aspects, so it will become very, very efficient for our industries to come forward, work on that particular thing, translate all the laboratory scale and pilot scale research that is being done at the academic level to be translated to the industry level. And that will be very good growth that we'll have. So these are few challenges with the production sector. So now let's move on to the utilization phase. So in the utilization phase, we have been discussing in this particular sector, is India ready to take the benefit of electric vehicle? This discussion we have started in the year 2017 onwards. So that's the slogan which we have started with. So why? Because we have seen that the diesel is creating huge amount of pollution at our level, and we move on to the electric vehicle and we feel so clean, and the problem has been shifted to our electricity production. The question mark in the electricity production, and immediately we have realized that the electricity production is playing a major role, and we have started phasing down our fossil fuels. And again, a new problem comes. So it's a cycle which is going on like that, and we go on solving them. So it's the think tank that makes it possible. So now let us move forward and understand what can we do. So when we have asked this question, is India ready to take the benefit of electric vehicle? So the work has been done by Vishwa. So he is a BTech student who was passed out in the year 2018. So we were interested in answering this particular question. And then we moved on to the electric vehicle shop. And we have one of our colleagues over here has taken his electric vehicle recently at that particular time. So we have taken the vehicle or there started dismantling it, not completely dismantling. We have started looking at the battery system, the charging systems that we have. Then we have visited the dealer which we have and asked him multiple number of questions about its performance, production activities, and everything. From where we have got different links with the units that they are being supplied, and we have done a very good amount of investigations over there. So post this particular one, after understanding this particular scenario, we have started developing in our inventory databases over there, and we have started comparing this with our internal combustion vehicle. So why I have given only a picture of electric vehicle there? We are well known with the internal combustion engine. So we have visited our mechanical engineering department to understand about the internal combustion engine vehicle, collected the data again, similar to the electric vehicle. So the inventory database collection remained the same. So in this particular process, we have considered the manufacturing system, the materials that are being used, the energy that is being consumed by taking vehicle mileage as the functional unit. So for a given liter of fuel, we have used petrol as the fuel for internal combustion engine. We have considered that particular one, and we have seen what is the mileage that it is giving. So a vehicle which is in good condition, well maintained, that's the vehicle we have used again. So So not the new one, and it is might have traveled some 5,000 to 10,000 kilometers in between, which is well maintained. So we have done an investigation over there, which is a very good vehicle, which is running over there, and we have considered that particular one. So how much distance it travels on single charge. Single charge, after charging that particular vehicle to the 100%, we have traveled along with that particular vehicle until it got discharged. So complete 100% discharge happened. So what is the distance? So the vehicle mileage has been calculated, and we have normalized that particular one to make our inventory data. So once we have done, we have conducted the impact assessment study by developing the inventory database. And interestingly, we have found that electric vehicle has huge impact on human wealth, but whether it is doing a very good job in ecosystem quality, climate change, and resources component. So then we have moved on to the next level. So we have seen the network diagram where which component is creating huge problem. We have seen more in the IC engine vehicle, it is the engine that is creating IC engine, and similarly the electricity, the battery unit which is there is the key critical component. The hotspot analysis has been done. So by understanding these two components, we have taken those two units exclusively to understand what is happening. So then we have taken the battery individually as one component, and IC engine is the second component. So post this particular one, we have seen EV battery production. EV battery production in the ecosystem quality is creating a good one. And similar, whereas in the human health also EV battery production is creating good. IC engine production is created wrong. It's like typical in the climate change and the resources. This looked very contradictory to our assumptions over there. Why? Because you have to bring out a lot of lithium extraction has to be done. And how come all these particular aspects were very lower in the quantity? So you can, why it is happening is the biggest question we have seen. And typically when we have started understanding the previous aspects, the human health, why it is very more over here, has been very clearly understood that EV battery production is the key contributing factor here, and even to the ecosystem quality, right? Except in the climate change component, and the bit amount of resources component, we have found this particular our result was valid. But at that time, the inventory database that we have was very limited to conclude this particular one. But yes, we have found the challenges. That's in the year 2018. That's why I'm showing the why I am pitching up this particular one is, so you don't want to have a very big statement at the first stage. So start collecting with the data that is available with you. Now the picture has very drastically changed. We have a lot of reports, people who have been discussing on this particular one. We have alternatives coming up. But at that particular point of time, we have found a critical problem with the EV battery production. So how do you recycle this particular one is the question came at that particular time. So we are told that the recycling policy has to come out, and the material recycling within the engines have to come out. The scrapping policies have been thought. We have started thinking about that particular thought process at that particular time with a very limited data. I'll always remember this particular. If you are going on a 1,000-mile journey, you have to start with the first step. So if you stand still at your location without any effort, and if you wish to reach your 1,000-mile journey, it will be very difficult. So with whatever data that is available, with whatever data resources that are available with our Indian context, let's start making the scenarios. So once you make the scenario, then we have a very beautiful component called human brain, human resource, which will certainly start accepting our results, criticizing our results. So certainly there are n number of viewpoints which come into our preview when they start looking at this particular results. I guess with the result which you have seen that we have got in the year 2018, you might have a lot number of questions which I may not be able to answer now because there is a huge amount of knowledge database that has been gained over the past 6 to 7 years that we have. So there is huge amount of literature which is available, which has addressed a lot number of problems where we have good amount of data that has been developed. So that's the start that we have to take. So this I have just shown you to make a thought process to the young brains like us, so that we can become one of the leading think tanks and task forces for the future. So post understanding this particular EV battery, then we have looked at each and every individual process. That is where I'm drawing conclusions from. So lithium hexafluoride production, aluminum production, battery separator, extrusion plastic clean, polythene, copper, latex, each and every component which is there, we have tried to look into that particular components, which is creating huge amount of problem over there. The copper production is one of the key critical ones. You can see that the blue marked ones. So now we have to go to the copper production system, understand what are the problems there, what are the alternatives for the copper we have to address. Then the dark green is the anode graphite for lithium ion battery production. Yesterday we have been listening from Professor Amaresh Chandra ji that lithium ion batteries are very, very critical, and we have to move towards the sodium ion batteries. So that's the beauty of understanding the individual level components. So this research has been done in the year 2000. It's like, I'll not say even research being done. We just tried to see whether it is possible or not by doing its small BTech project. And the results were very interesting, that gave a scope for us to connect with the material section people, mechanical people, manufacturing people, then with the physics, alternative storage systems, and the team is expanding now. There is a good amount of research wings that have developed, collaborations have been developed. You can see solutions being given. And in the past few days, you have listened to all these people, how we are contributing to this particular. So a small inquisitive question, a childish question that we have in our brain has given us a huge scope to do a very big amount of research. So dear friends, dear students, dear think tankers, dear future policymakers, and my dear technocrats and our elder generations who are giving us a huge amount of knowledge, just put up all these questions, give us solutions, so we can collaborate and make our India one of the great sustainable countries and forefront runners in the sustainable. So this is where I told you we were actually having a thought process like at that particular time, as since the picture which I have started, that the electricity shift has to happen. So in the 2018 time, when we have taken the energy mix, it is 67.9% with the coal. So and 12.4% is with the hydropower. And then we have taken 4 countries, let's like Brazil and China, which are very close to the Indian scenario mode with respect to population, with respect to the resources that are available at the energy mixes, and a very idealistic scenario with Norway. So Norway, you can see 0.1 is the coal, 3.2 is natural gas, and 95.2 is the hydropower. So we were like astonished, can we really get hydropower, like 95.2 hydropower in the Indian context? So to our astonishment, no is the answer. Why? Because the geographic location which we have, the systems that we have, we can't get at all the locations the hydropower. So okay, then what can we do? So we can rely on the other options is the question, and we can start increasing our hydropower. So we have made a sensitivity analysis by phasing down our coal and increasing the hydropower. And certainly there are other components like nuclear, solar, alternative components, which is certainly contributing. And now at this particular stage, we have reached this 56.7% coal usage. So within a period of almost 5 to 6 years, we have reached this scenario where we have 20% reduction, and hydropower is at the 23. I don't exactly say the hydropower, it is the renewable component is at the 23% or bit more that you can look in. It's like almost 45% is the renewable sections that we are looking in, where our hydropower might be at 16 or 17. And with that particular scenario, if I see the climate change, so from 100% to 85%, so there is 15% reduction in my climate change. So this is at the global level. Which might be so as Karthik ji, Karthik ji, can you so typically when you are moved to this particular one, the 15% reduction in the climate change is the potential that we have reduced. So what factors that I've considered, you have to do with the environmental impact assessment, substance flow risk assessment. So all these studies have to be conducted. You have to go with green technologies. So contribute at micro level. So the small components, when we are contributing at the micro level, will contribute to the macro level reduction. So shifting or lowering our 0.1 degree reduction from 1.5 to 1.4 degrees Celsius, if you want to move, many aspects have to be done. It's not just only the energy mix. The transportation sector, which you will be involved, has to be reduced. So huge amount of thought process has to be placed in this particular component. So you can do a lot of sensitivity analysis. So post this particular, this is also one of the small study that we have done. And again, in the year 2018 with a BTech student called Maharshi AV. Why I'm showing is like the people who are there, young brains which are there, who will be doing their BTech projects, MTech projects, just come up with wild ideas of comparison. Just think on this particular process, whether you have required data or not. So that particular time we are working on with a lot of municipalities at that period of time, going from smart city to smart city, understanding the system. So that there is a huge push on implementing this sort of small mechanical sweeping vehicles and big trucks of this particular sort. And are they really environmental friendly is the biggest question that we have got. Are we really doing justice to this woman who is doing this particular activity, who is earning there and being replacing with this with a machine, which most of the governments are trying to do now. So that's a simple question we have got, and we have started investigating. So we have made a simple system boundary. What are the utilities that are available? What is the equipment and packaging? So cleaning of the equipment has also been considered. So very simple system boundary, you can see. So we have went there, we have started speaking with the sweepers, what material they will be given. So post this particular one, so we have collected all the database, and these are common in both the systems. These gloves, shoes, personal protection units, then soaps, these are common. The things that are not common is this, the 3 components in the manual sweeping, whereas the battery, then the cleaning unit, electricity, and the PCBs in the mechanical sweeping. So we have dismantled all these particular components, and then we have collected the data over here, done our inventory studies again, and then we have started collecting the emission data. So you can see this is Maharshi, who is setting up his gimbal meter or their grim meter. Once when they're sweeping, this is for the manual sweeping. This is at the BC Roy Hospital location in IIT Kharagpur. So we have went and inquired when will be the sweeping be done. So we have placed this particular machine. The sweeping has been done. And similarly for the mechanical sweeping also, we have calculated the emissions, and that particular data has been used. And even prior to Maharshi, there was an intern who worked with Professor Brajesh, and even that data is also available. They have done a similar sort of study, and both that particular data and the data collected by the Maharshi were given. See, you need not require huge amount of funding to make small studies, right? You want huge amount of amount to validate that particular data. So you want to prove that particular technology, but to come up with a small conclusion, is it possible or is it not possible? We will have resources in our laboratories. So put that particular question, have that particular child in your life. So that doesn't require any funding for this particular one. So that question can be slowly translated into a small project, and you can do some preliminary experiments on that particular one, get some basic results. Whether your conclusions are right or wrong is secondary over here. And that things, when you question that particular each and every question, it's like the answers which are coming. Then if you see a potential in answering that particular one, write a proposal and tell the action of influence to your funding people. This is a concern that we have. This is the influence that you can bring. This is the solution for converting your concern to the influence. Funding comes into the picture. That funding schemes and everything is again a big discussion that we have, but this can be one of the smallest approaches to approach our funding people or the government people. And certainly, even if you go to the industry, people from the academic side, they get connected to this particular one. They certainly share their thoughts, and they do give you funding also. Why? Because it is also the industry people want the action of influence rather than the action of concern. So as academicians, we look at the concern and we translate that particular concern into the influence by putting up a research question and answering that particular research question. This is how we integrate nicely into the system. So post this particular results, we have got a nice understanding that mechanical sweeping has created a huge problem compared to the manual sweeping. But see the difference that is there. It is almost very, very less compared to 620 to 540 and 560 is a very small difference here. So both either mechanical or manual sweeping, when you're creating, both remain same. And specifically from the human health point of view, I would always love to say, when you are sweeping in your home using your broom, there might be some dust particles which flow and reach your respiratory problems. Whereas when you are using a vacuum cleaner, I may reduce that particular emissions which are flying into the air, a simple dispersion into the air. So I might have reduced that particular problem. It is similar to my electric car and biodiesel car scenario that we have seen. So same system, which is better, I can't question. But when I looked at from a social point of view, it's like 300 meters is the beat distance that they give for sweeping to a people, where I'm creating a livelihood to them. And just like in COVID, if I just wear a mask and take proper protection, I can go. So what we have told the municipalities is like completely shifting towards mechanical sweeping is also a problem. So slowly phase out that particular one, make a balance between these two. So that will be a very good solution for us. So rest all, like other conclusions are mostly on the social component sides aspects. So that we can discuss on in any other sections, or if you have that particular questions, we can discuss them individually. But from an environmental point of view, we have come to a conclusion here whether the mechanical sweeping is creating a more problem. Again, electricity is the big player that has come into the picture. Battery production has come into the picture. PCB's production has come into the picture. I can just go back and show you this one, the manufacturing of battery, manufacturing of PCB, electricity, and this particular steel brushes, etc., have come into the picture. And why manual has come into the picture? So the broom has to be produced. You're not just collecting the broom from somewhere and making your own broom like our Esther generation people used to make. But now there is a production process for this particular one also. So this is also producing, and the plastic bag is being produced. This plastic pan is also being produced. So these also have some component. Just using it's like biologically collected broom doesn't make it more economical, environmental friendly. So there is a production process for this particular one. I'm not saying that the growing of this particular broom is like the sticks that we have and this one, but the processing this particular one into this particular shape. So a wooden one you have to process that particular one, do some like paintings, etc. Finishing has to be done. So they use a lot of electricity activity. So we have to look into that particular industry also. Those have contributed to the system. So once you have looked into this particular critical components in the utilization phase, in the last session, in the day 2, when I've been discussing, we have seen how do you operate different payments, how do you collect huge amount of data for that particular payments in the it's like efficiency improvement in emission database development. So you take a payment and you do that particular payment project into 3 phases: construction, operation, and disposal phase, maintenance phases. So we have discussed it there. How do we collect the inventory databases? How do we do the impact assessment calculations over there from various reports that are available with us and the methodologies that are available. So I'm not going down deep into that particular one. So once this utilization has been done, we have lot number of vehicles coming out over here. So all these particular vehicles are to be scrapped out. Comfortably, you have to send them. There are huge number of policies that have been developed in across the country for the end of life management, even for the vehicle scrap policy. So Terry has done a very good job in developing this particular one with their think tanks over there, and they've developed a discussion paper, so which I'll be basically using over here to discuss. And similarly, our Prakriti, who is the mascot of our Mission Life program, is always telling reduce waste, reduce waste. So there is a need to balance this particular one, both at the policy level, both at our individual level. So when we wish to see the Scrappage policy, so let us look at the registered vehicles in India based on the vehicle segment. So two-wheelers have drastically increased. So in the year 1951, if you just see, the two-wheelers are very less in number, cars, jeeps are there, and buses are segmented, and goods vehicles are more. And slowly, as the time is progressing, 1960s, 70s, where the industrialization has happened. So there is a drastic increase in my two-wheeler vehicle, which has reached to a saturation here, So that's the component I would love to discuss with you, that now we have biggest question, how EV vehicles are increasing. There were few questions that were asked to many of our speakers in the previous days, that the growth of EV vehicle, will it not be a problem? So it will certainly reach to a saturation at some point of time. Now it might be increasing, but certainly at some point of time, there will be an equilibrium growth. So that means from an exponential to an arithmetic growth, it will be coming. So certainly, we will see with the electric vehicles also. We'll see with the different options that we are getting. So this is an exemplary situation with the Indian scenario itself. Now in the year 2019, if you can see, there are huge number of two-wheelers now, and the four-wheelers are being reduced, and the share of the four-wheelers, it's always in the percentage. So percentage is there, so the segment. So now the two-wheelers, and now I guess two-wheelers are increasing with the living standards that are going on. So by 2030, we may see there might be a reduction in the two-wheelers and increment in the four-wheelers. So car may come to a decline stage in my two-wheeler scenario. So with the huge number of two-wheelers and four-wheelers, which is almost 80%. So, and I remember we have a norm that 15 years is the lifetime, then post that particular one, you have to change your vehicle. So let us see that projected number of end of vehicles that we have. So that means how many are going to the scrap. And similarly, when I said Prakriti is there, that the individual level, how many of us are really maintaining our vehicles? How many of us are driving in the economy mode? How many of us are changing our engine oil? How many of us are switching off our vehicles during at the signals? So these are all the, again, questions that we have to place ourselves. Because yesterday we have Professor Amit Sinhaji explaining about a battery. So how do you use a battery to increase its life cycle or the design life? So the maintenance is the key critical component. Small aspects that we do, we can change a lot. We can increase our efficiency. We can reduce our resources utilization. It's like I remember. It's like I'll always remember his statement that when our battery, it's like phone is not working properly, we change our phone, but not the battery. So let's think in that particular direction. What exactly that we have to change? So in this particular projection in the year 2017, when they are projected, you can see the number, and slowly by 2030, you can see the number, how much it is increasing. Why? Because with the increasing population that we have, with the increasing needs of having two-wheelers and four-wheelers in all our places, so it becomes certainly an increasing, and certainly there will be a break even there for us, that the number of end of life vehicles will come to our scrap by, because the policies are being enforced. Certainly the vehicle with above 15 years of life has to be sent to the scrap. So post this particular one, so we'll see the percentage of materials being used in a passenger car and the major informal scrapping units in the India. So 16% aluminum, 5% plastic, 69% steel, so 4% rubber, 1% copper, foam, 1% glass, 2%. So there is a huge scope of bringing all these particular materials back into my system. So where I can avoid the production of the virgin raw materials. So it becomes very important important, very, very critical for every one of us to really understand how to reuse this particular one, how to remanufacture, how to redesign. There are many arts coming up now. So slowly, what could be a balance? So I have to increase my either informal sectors or the formal sectors. So these are the locations of the informal scrapping. That means there is a huge scope in this particular sector. So we have to bridge this particular gap. We have to start thinking in this particular direction and develop the startups. So there are central policies. What are the central policies and green tax in the Indian scenario? So these are the states which are implemented by at that time by the compilation done by the TERI. There might be few more states which are being implementing this particular one also. So the automotive industry standards have come into the picture. Then guidelines for environmentally sound facilities come into the picture. There's a Motor Vehicle Act and Fuel Acts which were discussed by Professor Uday Shankar ji. We have looked in. So we are progressing in the policies in this particular direction. We're trying to implement many systems, but can we really achieve this particular one? The question mark in the policy making again. So what are the challenges that we have? Infrastructure facility is a challenge, financial mechanism for vehicle scrappage. So there is a lot of scope in this particular sector, and the infrastructure facilities and financial mechanisms for it's a component again. Scrappage would not able to trigger a large scale scrappage of PLBs. Yes. So viability for original equipment manufacturers to set up end of life vehicle scrappage. So always the economics is the major component that plays a critical role when we are trying to develop this sort of units. That's what happens with our waste management sector also. What is the viability of the product that I will develop? And usage and disposal of hazardous materials in the vehicles is also a very big challenge that we have. And the evidence-based policy directives that we have to look in are the inspection and the maintenance, the regulatory environment. So the huge scope for doing the research, the phased implementation, then customer awareness, dispute resolution, recycling of materials, the subsidies and green taxes, that what we can bring. So that's where Prakriti will be also interested, that the institutions should do the research, industries should develop the incubation hubs, and governments to become the knowledge partners. So we all will become green, and achieve our sustainable development goals or the climate goals that we have placed. So thank you. So if you have any queries or questions, we will be very happy to answer. Let me check out in the chat box. You talked, Dr. Ravi, we see various LDCS studies being published from both academic and industry perspective. What aspects do you suggest to be addressed in order to make the LCA stand out? What aspects do you suggest to be addressed in order to make the LCA stand out? So specific to the Indian context, my point of view will be, first one is, as I said, we want many people to start thinking in this particular direction. We want to increase the PhDs, masters, and everyone from the academic side. So developing question in ourselves is one which brings, and certainly the industries are moving in this particular direction. Why? Because they have to submit many reports to the Central Pollution Control Board and other organizations, but still there should be a think tanks in this particular direction. Even they want many people. So start putting up the raising questions, and then we can improve on addressing few aspects. That's the first one that I would give. Second one is the inventory databases. So we don't have very specific database that is being developed to the Indian context, although some amount of progress is going on in this particular direction, and thought process is going on in this particular direction, specific to the LCA I'm speaking. So the think tanks that we develop, the people when they're working, we can develop standardized guidelines to this particular one. So we can develop different data template forms and then circulate it with all the stakeholders. So we'll start thinking, it's like we will develop a database. So this from the inventory data. Then from the impact assessment side, we don't have India-specific impact categories. We don't have India-specific sustainability assessment frameworks. So industry-wise, then sector-wise, we have to develop the frameworks and as well as the impact categories. And finally, interpretation, the think tanks has to come again over here, collaborate with each other. The industry should pose up the question, academics should solve these particular questions, and the outputs that have come out of this particular one, governments has to implement. There's a big task. So I hope there is a lot of homework that we have to do now, because we are working in this particular one, and we are the people who have to start producing results by 2030 and prepare our white-haired people and the experts in this particular areas who are in the policy making will start preparing us as per 2030 and 2050 scenarios where we have to transform. That's the sustainable development. So thank you. Hope I have answered the question. Romit Mitra. Thanks for the insightful talk. As India is mostly dependent upon agro products, how do you envisage the possibility of using a cocktail of feedstock made up of waste algal biomass and rice paddy based products for bioethanol production? Romit Mitra, I am not a biotechnologist, so it's a out of scope question for me, 100%. I guess I remember Romit Mitra. Yeah, I guess you're the biotechnologist. You're the right person to answer this particular one. But my viewpoint, if I have to put, I don't know, a cocktail of feedstock made up of waste algal biomass, rice paddy based, yeah, blending. I can look it as a blending component. Yeah, certainly from the environmental point of view, I'm reducing my conventional fuels. So these products can be very useful for us, and similarly for bioethanol production. So 100%, I was like, if we can collaborate, we can investigate on this particular system process, this blending scenarios we can develop, and we have to look in. But certain with studies that we have done in this particular area, the blending will certainly give very good results in reducing our different impacts. How much I cannot tell you now, but yes, this will be a very good component, especially for the strategies that we develop in the Indian context. This will play a very major role. And certainly, being a biotechnologist, we can progress well. Hope I have answered, or else you can unmute and give your viewpoints in this particular direction also. So any questions? If there are no further questions, are there any national associations of LCA? Yes, there is a national association called Indian Life Cycle Assessment, which is being run by, it's like taken care by the FICCI and other industrial partner. It's like associations which are there. We have Indian Life Cycle Association. So it is very active on doing this. Similarly, the CII has its own LCA wings and associations. So they do conduct a lot of LCA related experiments. And Rachel, I know that she's a nutritionist and working on this particular agricultural component. So we have association with Rachel. She is like, she has mailed Professor Brajesh, and we have collaborated with her in working, understanding the life cycle impacts, both from nutrition side and from the environmental side. So we're working in that particular direction. Hopefully, it's like within a year, we'll get you the results.
Thank you, sir.
If there are no further questions, then we'll conclude this particular session, and we'll have a 15 minutes break and we'll come back. So Darshan, I feel all objectives what you have put forward can be achieved by joint effort from all stakeholders. Hope you will achieve with Professor and his team as your support. Yeah, 100% Sudarshan. We are very open, and typically we have to thank all the people who have given us this particular work. We remember when we started in the year 2016 and 17 period, we don't have many people, many think tanks at that particular time who are really giving us an opportunity to work in the LCA. So it took time for the professor to make many people understand this particular one. And slowly it's in the year 2018 and 19 that we have started getting a lot of work. And the team got it expanded from our side. We have Rajarshi, then we have Subhashish Pradhan, lot number of people, then Tiwari. There are good number of people started working in this particular direction, and slowly the industry people started connecting, departments started collecting. Yes, I 100% agree with you that it's a joint effort that has to come, because without the octopus analogy, we can't achieve anything. So we are always open to the collaboration, and as many of you people know, Professor Brajesh is always one of our supporting person and inspiring person who gives us a huge amount of opportunity to put questions of this particular sort and give answers to it. So yes, you're most welcome, and just ping us on our WhatsApps, ping us on our emails. We are there to collaborate to make our nation a forefront runner in the sustainability domain. And you can put your questions here, we can discuss.